Today we will learn about different types of light fittings used at various situations. If you remember the last class, we have seen and learned the different types of luminaries, that is lamps, used at various places. These lamps can be used at different situations. The situations are like that, like this. If you take an industry where the people are working near the machines, the light should fall on the machine to do the work. That means this is called direct lighting. If you take a club or restaurant where only small lighting is required, that is, the light should not fall directly on the object, it should be reflected onto the upwards, only small light should fall on the object. This is called indirect lighting. Similarly, if you take a case of street lights or parks, gate lamps, where the light should fall, some light only should fall on the object and some light should be reflected upwards. So, therefore, the lights can be used at different situations. So, some can be seen through this. Lighting schemes, direct fitting. So, in this direct fitting, the illumination will be falling on the object about 90% downwards. Semi direct fitting, the illumination falls 75% downwards and 25% goes upwards. General fitting 50% downwards. Semi indirect fitting 25% downwards. Indirect fitting only 10% downwards. So, like this, the lighting can be used either direct fitting as a direct fitting or semi direct fitting or general type of fitting, semi indirect fitting, indirect fitting. So, these schemes can be used at different situations. You can see through this example how the direct fittings will be installed at various places. So, these are the various types of direct fittings. This is the total fitting. In this, lamp will be there accommodated, and this part is called reflector or diffuser, which will give the lights only at one place, so that the light should not escape in other directions. So, this fitting will be mounted on the ceiling, and from the ceiling the light will be reflected on the floor working space. So, these are the different luminaries, sodium vapor lamp or mercury lamps, etc. Similarly, other than this, even fluorescent lamps also can be used for the direct fittings. Direct fitting means the fitting should be fixed on the ceiling and the light should be reflected on the floor where the people are working, and these fittings will be used by using the reflectors. What is meant by reflector? The reflector is a device which gives the light only at one constant place, and the reflectors are made of vitreous enameled or anodized aluminum. If we use these materials, whenever the light falls on the reflector, it should be immediately reflected back. It should not absorb any light into it. These direct fittings can be used in many industries as well as commercial complexes, office, school buildings, etc. The next is semi direct fitting. Semi direct fitting means only 75% of illumination will be falling on the object and 25% will be diverted upper hemisphere. And generally, these semi direct fitting can be used for commercial buildings or commercial purposes where very high brightness is not required, and this can be used by using the louvers type of reflectors. Louver means you will be having a grill or small holes type of reflectors where the light will be falling into the object. Example, you can see this figure. This is a semi direct light fitting, the semi indirect and indirect. In semi direct fitting, this is called transient reflector, means only this rays or this light will be falling on the object, whereas this light will be thrown out to the hemisphere upwards. This is not useful, only this is useful on the object. So, this is called transient reflector. In semi direct light fitting, transient reflectors can be used. Then generalized fitting. In general fitting, we will be seeing in all our schools, in our houses, where the ordinary lamp or tube light will be fixed either to the wall or to the ceiling. So, this is called generalized fitting. In this, 50 to 60% of the light will be falling on the floor or the working space, and balance 40% will be passing upwards, that is upper hemisphere. And in this also reflector will be used, and by using the reflector, the light will be falling on the working surface, and all types of schools, commercial buildings, houses and offices, these type of general fittings will be used. You can see some examples on the general fitting. This is a general type of fitting where this will be used in commercial complexes or some office buildings. So, instead of plain louvers or plain diffuser or plain reflector, grill type of reflectors will be used, so that only some light should fall on the object. If you can see this figure, this is totally plain louver. So, entire light will be falling on the object. This is generally made of with acrylic cover. You can see some more examples. This is called semi indirect light fittings. So, that means only part of the light will be falling on the working space. This is office. So, like this, various types of fittings can be used as semi indirect fitting. So, you can see another example, semi indirect fitting. So, this is the reflector where the lamp will be fixed inside, and only part of the light will be passing onto the working space, and this will be thrown again into the upside. So, only this part will be useful in the working space, and these semi indirect fittings generally used where the parking spaces are there, much illumination is not required, and where the gate lights are there, either side we fix the gate lights. So, the light should fall only below the lamp, that is near the gate space. It should not give illumination on upwards. If it is giving, then we find a glare on that. So, these are the examples for semi indirect fittings. The last one is indirect fitting. The name itself shows indirect fitting means the illumination should not fall on the object. It should be directed to walls or ceiling. From there it will be reflected back to the object. Basically, these type of fittings can be used in clubs and restaurants where much brightness is not required. In clubs and restaurants, we used to see the object or we should not have much illumination, much light, only small and dim light should be there. So, therefore, in indirect lighting, 90% of the light will be thrown upper hemisphere, only 10% of the light will be falling on the working space or utility places. So, these are the various types of schemes can be used. Once again, the lighting schemes are: one is direct fitting, where 90% of the illumination will be thrown downwards, and semi direct fitting, 75% of the illumination will be used and 25% will be thrown upwards, and general fitting 50% of will be useful for the working space. In semi indirect fitting only 25% will be useful on the working space, and indirect fitting 10% only useful. When you use for a semi indirect fitting and direct fitting, high intensity of illumination is required, because only small percentage of light will be falling on the object. Therefore, high luminous intensity type of fittings can be recommended for these type of indirect and semi indirect fittings. And we have to design the lighting schemes. In designing the lighting schemes, we have to follow so many methods. One is, before designing, the illumination should be, average illumination should be considered, and the lighting should not be too bright and too dim. It should be very useful to a working person. And apart from that, some wastage factors also must be considered, and the light should not be overlapped. Suppose if we are fixing two lights side by side by keeping a suitable space, the light which is emitted by the one should not fall on the light 2. Similarly, the light which is emitted by the light 2 should not fall on the light 1. Then a shadow will be developed, or glare will be developed, glaring will be developed. Therefore, we have to consider all these factors before designing a good lighting. And before designing the good lighting, some of the factors to be considered. So, we will list out, we will go through one by one what are the factors. The first one is utilization factor. The name it shows utilization, that means when the lamp is emitting so much of luminous flux, so how much flux has been utilized by that object or working space, that is called utilization factor. How much light has been emitted by the lamp, in that how much light has been used by the surface, the ratio is called the utilization factor. Generally, whatever the illumination, whatever the light has been emitted by the light cannot be used by the working space, because the working space may be, the floor area may not be a smooth. If the floor area is very smooth, so the wastage will be very less. Similarly, the floor area, you have a rough space, so some light absorption be there due to the rough space, therefore some light is wasted due to that. And if we have a white lighting, white walls, so white walls will not absorb the lights much. Instead of white wall, you have a black walls or some other colors of walls, so definitely the color walls will absorb some light, therefore some light will be wasted. Definitely whatever the lamp is giving out, the light cannot be, same light cannot be useful by the working or surface area or working space. Therefore, the definition can be read like this: utilization factor, the ratio of total lumens received on the working plane to the total lumens emitted by the light source. Utilization factor equal to lumens received on the working plane by lumens emitted by the lamp. So, therefore, by considering all these factors, the utilization factor will be always less than 1, because due to the wastage, the light source which is emitted by the lamp cannot be utilized by the working plane completely. Therefore, always the utilization factor will be less than 1, and it varies from 0.3 to 0.5. The next definition is depreciation factor. Depreciation factor, if we go through our earlier subjects, is nothing but a sinking method or sinking factor, but here depreciation factor is nothing but a maintenance factor. That is, when a lamp is fixed today, if you will see the lamp after 5 or 6 days, definitely some dust will be formed on the lamp. So, when the dust is formed on the lamp, when the lamp is emitting so much luminous flux, so definitely the lamp cannot give whatever the luminous flux emitted, cannot give, because the dust will be covered by the glass cover or acrylic cover. Therefore, the light emitted by the source or lamp is not equivalent to the when everything is clean. Suppose the lamp is clean, so therefore the light whatever they emitted will be useful to the object or useful to the working plane. But after due course or after some days, definitely dirt or dust will be deposited on the covers or glass. Therefore, the brightness will be reduced on the floor or working space. So, this factor is called depreciation factor. The depreciation factor can be maintained 1 provided all the fittings kept clean, very neat, and every day we have to keep very clean, but it is not possible. If you see the industries, if you see the any office buildings, once we fix, unless the lamp fuse out, then only we can replace it, but we never clean it. But if we maintain the clean and very neat of this outer cover or glass cover, definitely the illumination level can be increased. So, therefore, the depreciation factor can be defined as ratio of illumination under normal working condition by illumination when everything is clean. So, the value will be around 0.8. This can be brought 1 if everything is clean. Waste light factor. Waste light factor, as we discussed now, if so many luminaries has been planned to fix on the wall or on the ceiling, so we have to maintain a proper gap between one lamp to another lamp. Otherwise, the light which is emitted by one should fall on the light emitted by the lamp 2. Therefore, generally this waste light factor will be considered as 1.2 for rectangular surfaces and 1.5 for irregular surfaces. So, even though we have a very good planning for designing the lighting, but some light will be overlapping each other. So, the waste light factor can be defined like this: when a surface is illuminated by a number of lamps, and the surface is illuminated by a number of lamps, there is certain amount of wastage due to overlapping of light waves, and the waste light factor will be rectangular areas 1.2, irregular areas it will be 1.5. Reflection factor, the ratio of luminous flux leaving the surface to the luminous flux incident on it. Reflection factor can be defined as ratio of reflected light by incident light. So, it is always less than 1, because incident light will be greater than the reflected light. Therefore, the reflection factor will be considered as less than 1 in the calculations or in the designing part. Then reduction factor. Reduction factor is defined as ratio of MSCP by MSCP, and we have seen in the last class what is MSCP and MSCP. MSCP means mean spherical candle power, MSCP means mean horizontal candle power. So, reduction factor means if the light is illuminating in all the directions, the luminous flux is emitting in all the directions, and the luminous flux is emitting only in the horizontal direction, the ratio between all the directions to the horizontal direction is known as reduction factor. So, while making a good design of the lighting, we have to consider the reduction factor also into consideration. Then absorption factor. See, we have discussed if the different areas will absorb the different level of illumination. If you see the black surface, or if you have a colored surface will absorb more light compared to the white surface. In white surface we can get good illumination, good brightness, because white will not absorb the much light into it, but if you use the color surface it will absorb very much. So, therefore, the absorption factor is defined as net lumens available on the working surface, net lumens available on the working surface by total lumens emitted by the lamp. And if it is atmosphere is clean, the value will be 1. If bad atmosphere, 0.5. If it is a rough areas, the absorption will be more. If it is a smooth areas, the absorption will be very less. So we have to maintain always smooth surfaces to maintain a less absorption factor. If it is a less absorption factor, means very good illumination you are providing to the working surface. So the absorption factor is net lumens available on the working surface, and but whatever the lamp has been emitted. So the ratio between these two is called the absorption factor. Space height ratio. While designing, this is a very important factor. We have to consider space height ratio. Space means if we are fixing the lamps at two different places by maintaining a suitable gap, and at what height you are mounting from the working space, and that also very important. If your the height is should be 2/3 height compared to the your space. If you are maintaining a space of x, so you have to maintain 2/3 of that x. You have to maintain the height from the floor level to the source level, that is from object to the source. You have to maintain 2/3 of the height compared to the spacing between the two lamps. So therefore, if the height is too high from the object, then you will not get, definitely will not get much illumination falling on the object. Therefore, space height ratio also you must consider for a good lighting. So it is defined like this: the ratio of the horizontal distance between the lamps to the mounting height of the lamp. Space height ratio equal to space between lamps by mounting height above working plane. Luminous efficiency or specific output, and we will be very doubt that always the luminaires will be available in watt or wattage, and we go to the market, we will ask for 40 watt lamp, 60 watt lamp, 100 watt lamp, but we never call for so much, it should give so much lumens output, we never used to say. So what is the ratio between wattage to lumens? So lumens is nothing but the light which is emitting, the luminous flux which is emitting onto the plane, and that can be compared with the wattage of that particular lamp, and different lamps will have a different lumens per watt. Example, fluorescent lamps, incandescent lamp, mercury, sodium vapor, all these lamps you have seen. Different lamp will give the different lumens per watt. Now you can see through this chart. Luminous efficiency or luminous output. Ratio of luminous flux to the electric power intake is called the luminous efficiency. That means how much power intake we are giving, but how much ratio it is giving out. And the power intake will be always in watts or kilowatts. Generally here only it watts, and the luminous flux will be measured in lumens. So therefore, the ratio between the wattage to the output lumens is the luminous efficiency. Now for incandescent lamp, ordinary bulb which we used to see in our colleges or in the houses, it gives 12 to 20 lumens per watt. That means each watt will give the luminous flux of 12 to 20 lumens. If we purchase a 40 watts lamp, the 40 into 20, that means about 800 lumens it used to give on the working plane. For fluorescent lamp, it gives out 75 lumens per watt. In each watt we will get the 75 lumens output. Mercury vapor lamp, it gives about 40 to 80 lumens per watt. Sodium vapor lamp, it gives about 100 lumens per watt, 100 lm per watt. The total lumens. So now we have discussed always the lamp output will be lumens. The lumens can be calculated like this. If you know the illumination, what is the illumination? The illumination is how much luminous flux passing onto the area. So therefore, it is given as area into illumination. Illumination equal to lumens passing on square unit or square area. So therefore, illumination is defined as lumens by area. Area will get cancelled, you will have only lumens. So, that is total lumens, and the total lumens is not useful on the object. There will be some waste light factor. So, we have to consider waste light factor, and after considering waste light factor, this total lumens is not useful on the object. So, utilization factor you have to consider, and depreciation factor also we have to consider. Therefore, total lumens equal to area of the plane into illumination into waste light factor divided by utilization factor into depreciation factor. Now, laws of illumination. In illumination there are two laws. The first law is called inverse square law, the second law is called Lambert's cosine law. The laws of illumination. Inverse square law, the illumination of a surface is inversely proportional to the square of the distance between the surface and light source provided. That means the illumination is inversely proportional to the square of the distance. D shows the distance between the point source to the working space, and I is the intensity of the light which is falling on the object. So, this can be better shown through this example. Now, this is the point source, we are considering only point source, and A1, A2, A3 are the areas which are having parallel. A1, A2, A3 are parallel to the point source, and from the source the lights are emitting, the light waves are emitting. Now, these areas are making an angle with the source, that is called omega. The omega is nothing but a candle power. We have seen the candle power is denoted in solid angle, solid angle is denoted as omega, and the area 1 is having a distance of d meters from the source. Similarly, area 2 is having a distance of 2d meters, area 3 is having a distance of 3d meters. Now, you can see the derivation part of this. For area A1, solid angle equal to area by square of the distance. This is the definition itself, says the solid angle equal to working space area by distance square. So, the flux on falling on the area 1 equal to luminous intensity into solid angle, that is I into omega. So, I into omega is nothing but A1 by d square. So, I into A1 by d square. Illumination is defined as luminous flux per unit area. Therefore, luminous flux is I into A, IA1 by d square into area is 1 by A1, that equal to I by d square, because A1 cancels here. So, therefore, the illumination equal to I by d square, it is proportional to the luminous intensity and inversely proportional to the square of the distance. Similarly, on area 2 the illumination is I by 2d square, 2d is the distance from the source to the area working space. Similarly, E3 equal to I by 3d square. If these formula will hold good, if the illumination is falling horizontally on the plane, but it never occurs, always it takes some angle. So, the angle, when it is taking some angle, so we have to consider always that angle also into the consideration. Now, you can see through this figure. Now, this is the source and this is the working space, AB is the working space and having a distance or height of h meters, and this source is having a distance of d meters from the working space. AB is the normal working space and CD is the vertical space, can be defined as AB by cos of the angle cos theta. So, from this we can derive, if the light is falling in an angular manner, instead of taking illumination intensity by d square, we have to consider the cosine of the angle also, that is the illumination at CD equal to this illumination at CD equal to I by d square into cos theta. I is the luminous intensity, d is the distance from the source to the object, and the cosine of this theta angle also we have to consider. So, the second law can be defined like this: the illumination E at any point on a surface is directly proportional to the cosine of the angle between the normal at that point and the line of flux. Therefore, E equal to I by d square cos theta, and sometimes not only cos theta, cube of cos theta also can be considered. Therefore, Cp by d square into cos cube theta. So, now we have seen the how the light fittings can be used at the different situations, and before designing the good lighting, what are the factors has to be considered, and to make a good lighting, that is to calculate the lumens, what is the formula to be used. So, by considering all these factors, we have to do some exercise problems. Now, I will read out the problem, then you have to give me the one by one step how to solve this problem. Now, the question is, when a 250 volt lamp, takes a current of 0.8 amps, that means a lamp is having a voltage of 250 volts taking a current of 0.8 amps, it produces a total flux of 3260 lumens. That means the light output is 3260 lumens. Calculate MSCP. Here MSCP means mean spherical candle power, of the lamp. So, we know the MSCP equal to the total luminous flux output by the 4 pi, because in spare we have to consider the 4 pi. So, therefore, the method of solving this problem is MSCP, mean spherical candle power, equal to luminous flux output 3260 divided by 4 pi. So, if you solve this, you will get the answer of 259.42. The MSCP equal to 259.42 is the answer. The next step is efficiency of the lamp.
Hello.
Yes.
Sir, I would like to know what is absorption factor.
So, absorption factor means when the light is mounted on the ceiling or the wall, when the light is falling on the object, so the object will absorb some light due to the color or rough surface. This is called the absorption factor. So, now efficiency, to calculate efficiency of any machine or light, the efficiency can be calculated if you know the output by input. Now, here the output is luminous flux, that is 3260 lumens is given, and the input of the lamp is the voltage and current. So, here the lights are used for AC, assume that. Therefore, we have to consider the power factor also. So, the input equal to, we know the formula VI cos phi, but for lighting the cos phi is always 1. So, therefore, the lamp efficiency equal to output by input. Output is lumens, that is 3260, input is voltage, current and power factor. So, if we solve, then we get the 6.3 lumens per watt. So, therefore, in each watt we are getting about 6.3 lumens. So, we can go for a next problem. A surface inclined at an angle of 70 degrees, that means a source, point source is mounted, and the light which is giving, or the luminous flux which is giving at 70 degrees range, it is not falling directly, it is not a direct light. 70 degrees to the rays is kept 4 meter away from a 125 candle power lamp. Find the average intensity of illumination on the surface. Find the average intensity of illumination on the surface. So, here you can see the figure. So, this is the your source, point source mounted here away from 4 meters, making an angle of 70 degrees. So, if you draw the vertical line, this makes 90 degrees, this is 90, 70. So, this must be 20, because the total angle between the triangle is 180 degrees. Therefore, the theta equal to 90 degrees minus 70 degrees equal to 20 degrees, or this total is 180. So, here 70, this is 90, the balance should be 20 degrees. So, illumination, we have seen illumination for this type of object, it is not I by d square, it is I d square cos theta. So, I d square cos theta. So, here the I is given from a 125 candle power, that is Cp, by distance is 4 meter, 4 square, cos of 20 degrees. So, you will get 7.34 lux. Illumination will be always measured in lux. The answer is 7.34. Another third problem is a room 10 meter into 15 meter is illuminated. That means here he has considered a room. So, the room dimensions are, the length is 10 meters, the width is 15 meters. That means the square area of the room is 10 into 15, is illuminated by 1500 watt lamps. So, in that room 15 lamps are fixed of each 100 watts. The luminous efficiency of the lamp is 40 lumens per watt. So, the luminous efficiency of the lamp is, in each watt it is giving out 40 lumens. So, how many lumens total it is giving? 40 lumens per watt. How many watts are there? 15 into 100, 1500 watts are there. So, this 1500 into 40, you will get how much total lumens output we are getting on the working space, and utilization factor is 0.5. That means total lumens are not utilized by the object or surface. So, some wastage is there, that is 0.5. Find the average illumination. So, the average illumination, yes,
sir?
yes.
How much luminous flux emitted by tube light per watt, sir?
So, generally the fluorescent lamp, also called tube light, the tube light will emit 75 lumens per watt. So, this problem can be solved like this. We know the room area 10 meter into 15 meter, that is 150 meter square. The total wattage, there are 15 lamps, each is having 100 watts. So, 15 into 100, 1500 watts. Total flux radiated, the total flux radiated equal to, in each watt it is emitting 40 lumens. There are 50 lamps, each lamp is having 100 watts. The total wattage is 15 into 100. The output is per watt 40 lumens. So, if you multiply 1500 into 40, it will give the total lumens illuminated on the surface. So, the total flux radiated equal to 1500 into 40, that is comes about 60,000 lumens. But these 60,000 lumens is not utilized completely, because the utilization factor is 0.5. What is meant by utilization factor? Utilization factor is the total light which is emitted. How much light it is emitted? 60,000 lumens. These 60,000 lumens are not falling on the object. About 50% it is going on wastage due to the bad atmosphere or due to the bad surface, due to the color surface, etc. So, therefore, the actual flux reaching on the working space equal to flux into utilization factor 60,000 into 0.5, it comes about 30,000. So, now average illumination, what is meant by average illumination? The illumination or the luminous falling on per square meter area. So, we have to divide with the room area, that is 60,000 into 0.5 is the total flux by a room area is 1500, that is 150. So, 60,000 into 0.5 by 150, it comes about 200 lux. Always the illumination will be measured into terms of lux. So, illumination equal to 200 lux. So, now we have seen the different types of questions. Now, we can have some object type of questions. So, we will go one by one. Unit for solid angle is A, is it radians? B, is it nit? C, is it joule? D, is it steradian? Unit for solid angle, radians, you know radians only for plane angle, it is measured in radians. Nit is used for brightness, not for solid angle. Joule is a mechanical term used for the energy. Steradian, so this must be correct answer. Unit for solid angle is steradians. The second question is, normally utilization factor of illumination will be, we have seen in many terms the utilization factor never be 1. So, the A answer is 2, it cannot be 2. B 4, it cannot be 4. C, it is 1. It is very highly not impossible to have a utilization factor 1 until unless we take all the precautions, even then also it will be less than 1. So, the answer is D equal to less than 1. The third question is, what are the units for brightness? The units for brightness, lux. Lux is not the units for brightness. Lux is the unit for illumination. B, radians. So, radians are units for plane angle. C, candle per meter square. Is it correct? Let us check D, lumens. Lumens is only, it is a unit for luminous intensity or candle power. So, therefore, the C is correct, candle per meter square. The brightness is so much candle power per unit area is denoted as the brightness. C is the correct answer. The fourth one is luminous efficiency of sodium vapor lamp in lumens per watt. 20. It is the lumens per watt for incandescent lamp. 80. It is for tube light for fluorescent lamp. C 100, and check the D 40. It is also not correct. So, 100 lumens per watt is the correct for the sodium vapor lamp. Next, we will have some fill in the blanks type of questions. Question 1 is, illumination is defined as dash received by the surface per unit area. So, we should know what is the illumination definition. Illumination is defined as dash received by the surface per unit area. The answer is luminous flux received by the surface area. You have to write luminous flux received by the per unit area denoted as illumination. The second question is, the ratio of space between lamps to the mounting height is known as dash. The ratio of space between lamps to the mounting height is known as dash. So, it must be space height ratio. Space height ratio is defined as lamps mounting height ratio of space between the lamps to the mounting height is known as space height ratio. So, in the today's class we have learned about different types of lamp fittings used at different situations, and they are direct fittings, semi direct fittings, indirect fittings, and semi direct fittings, generalized fittings. And before designing a good lighting, we have seen what are the factors to be considered, like utilization factor, absorption factor, reflection factors, waste light factor, etc. And for a good illumination, we have derived the formula that illumination equal to I by d square, that is d is the distance between the object to the source, and if the light is falling directly on the vertical plane, this formula can be used. But instead of that, if it is making some inclination, we have to take the I by d square cos theta. So, we will see different types of light fitting constructions in the next class. Thank you.